Hello guys, how are you doing? I hope you are doing very well. So guys, today we're gonna talk about gravity, normal force and applied force. Let's see what is gravity, what is normal force and when does it happen, and what is applied force. Okay guys, let's start. Bismillah. Gravity is a force which attracts or pulls things toward the earth. It means it's a kind of pulling force. Pull everything to the earth, okay? Gravity pulls everything to the earth. That's gravity. For example, when we stay here on the earth, it's all because of the gravity. Otherwise, we are going to, kind of floating, we'll go up when in any other times, okay? Suddenly we'll go up because if there is no gravity. But because we have gravity, gravity pulls us to the earth. Because of this, we will stay on the earth. You see, everything is around us, it's on the earth, right? Whatever is, it's like your phone, your iPad, computer, whatever you are here, for example, right now. Now it's on the earth, and you are on the earth. Everything around you is going to be stay on the earth and not floating, not going up. Why? Because of the gravity. Gravity is a force which pulls, or we can say attract things toward the earth, okay? Pulls everything to the earth. For example, if you look here, you see that this girl kicks the ball, right? So but after a while the ball will goes down, you see, change the direction to downward. It will go up maybe for let's say 100 meter, okay? But at least in one point it will come back to the earth. When? Why? Sorry, it's all because of the gravity. Gravity pulls down. And you see the apple here. You see there is an apple here that is just gonna fall off. Why? Because of the gravity too. Gravity pulled them down. Otherwise, the apple will not fall off. They will go up. But because it fell on the ground, it means something pulled it to the earth. And guys, we have to know this too. Gravity works on both objects at rest and when they are moving. It means gravity is not only for one object which is at rest. It means it's stopped. It's not only for an object which is moving, okay? It's for both of them. While you are moving, while you're stopping, you have gravity. Whatever around you, if it is stopped, or I mean at rest, or if it's moving, it has gravity. You know what? For example, if gravity is only for at rest, while we are moving, while we walking, running, any other things, during our moving we are floating, we are going to go up until we stop, then we will come back down. It means if it's only for stopping, for things at rest, for whatever moves around you will go up, will float. Like people in space, you have seen many videos, right? The people in the space, they're floating, they cannot go for any other particular direction. So but if we said that if it's only for rest, I mean the object's at rest, when you move you will go up, you will float. And also at the same time, if it's only for some the things that they are moving, it means if you stop you will go up. It means when you are moving, okay, you have gravity, you will stay on the earth. But if you stop directly, you will go up. So if gravity is not for the rest, it means when you stop, you will go up. So by the way, in this case, if gravity is always only for moving, during sleeping you have to move. You will never stop. Okay, even during sleeping, you will never stop. Because if you stop directly, you will go up. Maybe you will be disappear later. you know so that's why say alhamdulillah we have gravity, that we can move, we can stop whatever we want and nothing gonna happen to us. So alhamdulillah. So it means we have to understand that whatever is at rest or whatever is moving has gravity. Everything around it has gravity. Maybe someone will tell you that, for example, give you a picture or whatever is around you, say tell me what are the forces act on this object. The first thing, just say gravity. It's on the earth, okay? 100% it has gravity. Whatever is on the earth, it has gravity. So this is an example for object at rest. The apple is at rest, right? It's not moving, but suddenly it's fall off. And the ball is moving. It has gravity too. It means if you are moving or it's at rest, it has gravity. Something will pull it. A force is going to pull it. So that's about gravity. Let's go for normal force. So normal force is a support force that occurs when an object has contact with another object. It means for normal force, we must have contacted objects. Without contacting, there is no normal force. Normal force always acts opposite to the applied force. For example, there is gravity, pull the books down, right? So the gravity pulls the book down. But in here and here too. But in here, the table is going to be the normal force, a support force for the book. It doesn't let it to fall, okay? If we don't have normal force, the book will fall on the floor. But because of the table, it's support force, it's normal force, push it up. The gravity pulls down, but the normal force push it up. That's why the book will stay in its place, it's not gonna fall, okay? In here too. In here, the hand is going to be normal force. Why? The gravity, like this one here, the gravity pulls down, but the hand pushed up, exactly like here. So, and that's about normal force and gravity. Gravity, we said, attracts or pulls everything to the earth, if it's at rest or moving. Normal force, we said, it's a kind of support force that for two things when they are at rest. Okay? Gravity, for example, pulls down, something will be pushed up. Opposite. It said always opposite to the applied force. Now the applied force on the book is gravity. Gravity pulls the book. You see? But normal force is opposite. It means push it up. Pulling, so the normal force will push it. We said opposite. And you have to know these two, guys. Forces act in pairs. It means we don't have any single force on the earth, okay? We must have pairs. When we have an action, we must have the reaction. Action, reaction. One force, we have the opposite force too. Now, gravity pulls, the normal force push. You know, we have two. At least we have two forces. So, and guys, we have applied force, which is a force exerted on an object. For example, when you open the door, or when this man pushed the whatever it is, table or whatever it is, so push the object. So this is applied force. The man exerts force on the object, or this girl exerts force on the door to open it, or maybe to close it. So it means for opening, for closing, for moving, for picking, for throwing, for whatever you have, you have to use force. For pushing, for pulling, for picking, for throwing, whatever you have to use force. We call this force applied force. This force that you are using for doing something, this is called applied force. Whatever you do, I don't say which thing, whatever you do, when you use force, this is called applied force. For opening a door, you must have applied force. Otherwise, the door will not be opened, okay? So, what's applied force is the force that exerts on an object. When you pick your phone, for example, exerts force to pick it. When you push something, when you pull it, you are applied force on this, exerts force on this. So these are about gravity, normal force, applied force. Gravity is a force pulls or attracts things to the earth, pulls everything to the earth. Gravity works on both objects at rest and when they are moving. It means it doesn't matter that where they are moving or they are at rest. They have gravity. Like these two examples, the apple which is at rest and the ball which is moving. So, and normal force is a support force when an object has contact with another object, okay? So we say always opposite to the applied force. Now, the gravity pulls things down, but the normal force push it up. So, forces act in pairs, 100%. For each action, we have reaction. Now we have gravity. For the reaction of the gravity is normal force. You see, gravity is the action. The reaction is normal force. So applied force is any force exerted on an object. Any forces which will be exerted on another object, we call this applied force. For doing whatever you want around you, you need a force. This force called applied force. Whatever you do, you apply the force on this one, okay? So be careful. Guys, this is about gravity, normal force, applied force. But something is here very important for the forces. You have to know. These arrows are very important. So, by these arrows, we will know these things. One, the direction of the force. The force is for which side? Wants to move what to where to where, which side. And the amount of the force, how strong it is. And also the change, what gonna change and according to what. This arrow will tell us how is the change. The change is happen to which side. What gonna happen? These arrows. These arrows will tell us these three things, okay? What are they? The direction of the force, the amount of the force, and also the amount, the direction, and the change. So these three. Guys, let's see what are they. Two of them are really easy, really easy. For example, in here, we have these two arrows here, A and B. Sorry. So, you see that the arrow of A is larger than the B one, right? So easy. The larger arrow is stronger force than the smaller arrow. It means when we have two arrows, one is large, one is small, it means this arrow, the larger arrow is strong. It means a larger force than the other one, the smaller one. It means if the arrow is big, it means the force is greater. If the arrow is small, it means the force is less. So this is one of them. By the size of the arrow, we will understand. If it's large, it means the force is more. If it's small, the force is less. So this is one of them. And the direction, so easy, this one. For example, this arrow is from what? Left to right. It means the force is acting from left to right. For example, this man acting, pushing this from left to right. You see, it's moving from left to right. You see, the object moves from left to right. So if it is from, you see, it's like that. The direction is toward the, toward the left. It means from right to left. You see, this direction is to the right. It means left to right. This direction is to left. It means right to left. So these two are really easy. One is direction, one is the amount of the force. So the size is going to tell us the amount of the force. If it's large, it means the force is strong. If it's small, the force is less. And the direction, if it's to right, it means object moves from right to, if it's to right, object moves from left to right. If it is toward the left side, it means object moves from left to, right to left. The directions are really easy, and the amount. Something else is here, guys. This is very important. Which one makes the change? So right now we have friction, which is opposite of the applied force. The applied force of the man is pushing this from left to right. You see the arrow? Left to right. But friction is working in opposite direction, which is makes them slower. The friction makes them slower, makes the man and the object slower. But so the applied force is left to right, it means the friction is right to left. It's always opposite, always. So, but why the object is moving? If you have another force which is to left and one force is to right, why the object moves from right to left to right? One force is from left to right, one force is right to left, but the object moves from left to right. Why? What's the difference between the force of left to right and right to left? So this is the reason. Because the arrow of left to right is larger than the other arrow, it means this force is more. Which force is more? This one will decide about the change. Okay? This force is more, so it means the object moves according to this force. Whatever this force wants, the object will do this. This force will decide about the change. Sorry. So, now we understand these three things. One is the size of the arrow. If it's large, the force is more. If it's small, the force is less. And the direction, you see that the force is from here in this one A is left to right, but in B is right to left. The direction is so easy, and the amount also so easy, because it's all about which way the arrow is moving, and also the size of the arrow. But this one, be careful. We have two forces. Which force, which arrow, we know that we said in here, which arrow is larger, it means this force is stronger, right? This force is more. So because in here this force is more, this one, it means this will decide about the change. This will decide what's gonna happen. For example, this force said I want to move from left to right, so the object will move from left to right. But if this force would be more, the object will not move to right, left to right. The object will follow this arrow, because this one is stronger. The object will follow the greater force. Which force is greater? The object will follow this. Now, this arrow is larger, it means this force is more. So the object will obey and follow this arrow. Whatever this arrow said, this is the change. This arrow said that move from left to right. The force said that I want you to move from left to right. That's why the object, you see, move from left to right continuously by the man's hand. Okay. But this one is smaller. But if it would be bigger, it means this one will, the object would follow this one. It said right to left, the object would move opposite, from right to left, not from left to right. But now, because this arrow is larger, that's why this arrow will decide about how the object moves, how the change happen. So that's it. Gravity is a force which pulls or attracts everything to the earth, and gravity works on both objects at rest and when they are moving. Like here, the apple is at rest and they will fall because of the gravity, and the ball is moving but still it has gravity. It still has gravity. And normal force is a support force. We said that but we must have objects that contact with another object, like this gravity with a normal force. So it means there is a contact between the table and the book. That's why gravity pulls down, we have normal force. When we have objects, they have contact, we have normal force. Sorry. And always in opposite direction, acts on opposite. Forces act in pairs. We said that when we have action, we have reaction. When we have a force to right to left, we have one from left to right. When we have a force from up to down, we have another force from down to up. You see? An applied force, we said, is any force exerted on an object. You open a door, pull a drawer, pull a chair, moving a table, a box, wherever you have it. When you do something around yourself, you need force. This force called applied force. And guys, according to these arrows that you have understood that here, in here, for example, you see that two forces are acting on the book. One is pushing, one is pulling, but the book is not moving. Why? So that is what I said. The size of the arrows. Look here, guys. Look at this part. You see that this arrow and with the other one has the same size. Okay, why the same sizes? So because of this, we understand that the arrows had the same sizes, means the forces are equal. We said which arrow is larger, this force is more. But now they are equal. They are the same sizes. It means none of them are going to be larger. They are equal. That's why the book is not moving. For example, if you have two people, okay, one person here, one from right, one to left. If they are pushing the table, if their forces will be equal, the table is not moving. But if this man in right is stronger, the table will move to left because it's pushing to left. If the left one is stronger, the force is more, the table, because he is pushing to right, you know, the left one push it to right, that's why the table move to right. That's why when the forces are more, this the stronger force will make the change. But if they are equal, nothing gonna happen. Like these two, we said that one here, one there, one right, one left. If their forces are equal, the table is not moving. They are pushing. Two forces act on the table, but the table is not moving because the forces are equal. In here too, the gravity is equal to the normal force. That's why the book is not moving. Not to up, not to down. So normal force push it up, gravity pulls down, but the book is not moving for up or either for down. So that's all the lesson. I hope you understand, and best wishes, inshallah.